Hi, everyone. Thanks for coming to GraphQL conference, I guess. I'm Adam Malone. I lead solutions engineering for Hasura. I've been in San Francisco for about 6 weeks now, so I'm getting used to what it's like to live in the city. I'm getting lost, all of that kind of stuff. Today, I decided to give a talk on the future of GraphQL, and the reason for doing that is because a lot of the customers that I'm working with, they've got this in their mind. They're like, okay, we want to adopt this technology, but we want to make sure that this is going to be resilient for us as we move into the future. And I think in any kind of technology, there's a maturity curve, the hype cycle, all of that, but then there's a maturity curve that comes with that. And I think this is both what you'll see in certainly some of our product messaging, but I want to talk as an architect today. So a little bit about me. Like I said, I just moved from Sydney. I've worked in open source for pretty much my entire life, and in many different roles. First, I was a really bad developer, and then I did a whole bunch of other things before finding my way into solutions engineering, which is really a fancy term for me saying I'm an architect that talks to architects about their architecture. You'll find me in most places online under this name, Typhonius. And if you're like me, you'll probably wonder what that name means. If you Google that name, it will look a little bit like this. This one is me here, just so you know, like it's not one of the frogs. I invented this when I was a kid, and I thought I've invented this. It was actually just a species of toad. So happy coincidence or something. So the things that I'm hoping that you'll take away from today, there's a few different things I want to run through. I'm going to kind of make a big statement up front. Then we're going to walk through a couple of things around what governance is, what metadata is. I'll show you a little bit of a demonstration of kind of how these things come together, and then we'll talk a bit more about kind of GraphQL's future. So diving in, why do I care about the future of GraphQL? And the reason for this is I see this graph a lot, because architects show this to me. They say, hey, it looks like you guys have peaked. And just like me, who peaked in high school, I have to kind of say, that's not the case, right? Like, there's reasons for this. And when we look at this graph, it kind of goes, okay, maybe we should be thinking about other technology. We're looking for like the shiniest new thing. Like, this is the contentious statement. But what I'm seeing actually more kind of now is that there's a maturation in GraphQL. And a lot of organizations, they're kind of hyped about it less, but using it seriously, like using it in action and using it for production grade systems, which for me is super exciting. So for me, when I see this graph, I think this is actually really good. What we want to try and do is we want to try and make GraphQL enterprise grade. So it's less about being hyped, less about being the shiniest new thing, and more about being a tool or a platform that people are starting to use in real life. So the reason for this, and the reason that I think we're seeing a drop-off, and the reason that I think I wanted to do this talk, was because in a lot of architectures that I look at, a lot of the architects, they go, yeah, we throw GraphQL up here. GraphQL exists to provide some kind of API endpoint to mobile devices. It exists to provide that kind of front-end framework. And the reason for this is that the enterprise architects who are responsible for designing, you'll often hear like these next-gen systems, they've got other things on their mind than the type of technology that they're using. The reason is they're kind of thinking about things from a governance standpoint. They're thinking, okay, we don't really care about like what boxes we're putting in this. What we care about is that the boxes are going to be safe and secure, that we've got good traceability between those boxes, that if I get audited and my boss comes to me and says, hey, I need you to find out how this data got from this system to that system, there's a kind of a dedicated trail that we can take that understands how that data moves between different systems. And so the reason for this, I think I'm standing a bit far away, there we go. The reason for this is that in most cases, this has been kind of the architecture demode for however long. And architects go, I know how to deal with this. Anything up here, this is an implementation detail. I know that I'm going to give the teams who need access to the data control of that data. Those teams are going to then provide me with some REST services, usually REST services, a big swarm of microservices to enact access to that data. And then whatever anyone does up here, that's kind of out of the data pathway. That's out of like the critical path for data flow between systems. So I want to pause for a second and kind of ask, what is governance? Like any person who has lived in the last like 1 year, 2 years, I took this question to ChatGPT, and I said, what's governance? And it gave me this big, long blurb that, because I don't have the attention span for that because I spend too much time on TikTok, I said, can you explain that like I'm 5? And again, this was far too much effort for me to read, so I said, even simpler. And it said to me, GraphQL is basically like having a bunch of rules that everyone has to, sorry, governance is like having a bunch of rules that everyone has to follow. If we all follow those rules, we can all play nice. And I think it's a really good analogy for how we should take governance in an enterprise ecosystem. We want to make sure that everyone's following the same rules. We want to make sure that everyone's using the same protocols, that everyone's securing data in the same way, and that we have the same oversight of the data in the same way. So really, when we think about governance, governance is really about having the rule set across the enterprise for the data that we're using within the enterprise itself. Now, as an architect, these are some of the things that I talk to other architects about, and these are the things that they are most concerned about when they're building these enterprise ecosystems. So way before they're deciding how they're moving data between system, from system A to system B, they're kind of thinking about these things here. And a lot of this is driven by things like commercial outcomes. For example, are there value creation opportunities from this data? How are we able to commercialize this data? Maybe we're able to do this because it's faster for us to gain access to this. Do we have good traceability and lineage across the data that exists within the system? Because if the regulators come knocking, we need to ensure that we've got all of that ready to go. Similarly, my favorite one, third down on the left-hand side, it's this idea of decentralized ownership and federated governance. We want to decentralize ownership of that data, because I don't know about your data. You know about your data. You know about the system that's using it. You know how it's related to other things. You know how to tag that data. What I care about as an architect, as an enterprise architect over the whole system, is that that governance is federated up to me and to my team to make sure that I'm controlling that data from an overarching perspective. So these are the things, kind of the 8 tenets that a lot of architects will mainly come and speak to us about and mainly come and speak to me about when it comes to things like how do we produce the next-gen system? How do we make sure that when we're building, when we're architecting, we're not architecting ourselves into either a corner or into a trap set by regulators? And the thing that comes up a lot, and it comes up more and more, I saw an article, like a Salesforce article, oddly enough, about this the other day. A lot of this is now going to start to be driven by metadata. Metadata, being kind of core to the drive towards governance. And so again, when I Googled it, I said, what is metadata? It's everything but, and Google told me it's everything but bagel seasoning. So that was interesting. But really, metadata is everything but the data. So if we think about the kind of how we're trying to create data products, how we're trying to commercialize things, metadata is everything around the data itself. If we're building a data product and I'm looking in my app, I might see my name, I might see my list of products, I might see my purchases. But you better believe that there's probably about 10 to 100 times more data than that in metadata alone that powers all of that system in the enterprise. There was a study done a few years ago in Australia because we started collecting metadata from everyone who makes a phone call. So you make a phone call, you send a text, the government was like, we're not going to read the text, we're not going to listen to the phone call, but we will store the metadata. And the amount of data, kind of hardware and storage space required to collect the metadata of just, I think, 25 million people in Australia dwarfed the amount of data dwarfed the amount of storage for the data that existed, because so much data was being generated that was pure metadata. So to put this in the most simple way, data is the object, and metadata is everything around the object itself. If we put this into a slightly less toddler-friendly version, what we can see here is its customer records, its transaction records, it's all of that kind of thing that we might describe to create a data product. But when we start to look at all of the metadata that follows around that, it's things like who owns this customer, who owns this person, who's responsible for this person. It's things like how sensitive is this data? Oh, this is PII, or this is HIPAA. It's related to who created that, the audit trail that is involved around creating that person and their journey through the system. It could also be how that data was loaded into the system, maybe the ETL pipeline and the different processes that came through that. And so all of this here, just to kind of construct a single customer record, means that there's both this enormous interplay between data and metadata, but also an enormous amount of data that we need to start being aware of. So this got me thinking, how is this familiar to GraphQL? How can I tie this back to the conference that we're in? And I started to think, well, hold on. Like, a lot of GraphQL is actually kind of metadata, right? It's kind of self-declarative. It kind of defines what it is. So if we look here, we've got, this describes the data. It's this integer value. Or we've got, that field there is deprecated. We don't use that anymore. So there are already some shades of metadata that define the data that the GraphQL schema is presenting. So I thought to myself, if we could take this further, if we could make this more declarative, if we could make this more rich in the data, is this a way that we could make GraphQL more attractive to, say, those architects who are trying to find ways to ensure that the data within their system is rich in metadata itself? I think the challenge with this, and if you've ever used GraphQL or you've ever implemented GraphQL, there's a lot of things that I hear both today, and I edited this with some things that I heard today, or things that you'll have found yourself. So if we think about GraphQL, trying to move GraphQL down the stack, like that, trying to move GraphQL down the stack is difficult because we're having to build a lot of the code ourselves, we're having to build the resolvers, we're having to try and adopt methods to build authorization into those resolvers. No one wants to do that. What we want to do is we want to try and create this metadata that describes this schema, describes this GraphQL in a way that is more of an output than an input. So we're presenting that schema as the output rather than writing that schema itself as the input. So thinking about the future and thinking about how we can then push GraphQL down the stack, I started to take an approach of saying, let's take a more metadata-driven pathway for this. So this is where I'm going to say, OK, rather than being GraphQL federation, rather than being schema stitching, we should be thinking more about creating a semantic data layer. And in a semantic data layer, it means that we can combine data and metadata together. It means we get access to both at the same time. Now, GraphQL itself has some components of metadata, as we saw before. We saw that there was some rich data that described the data purely within the schema that other things can read, and they can say, hey, this field is deprecated, or this is related to this, or this came from over here. And effectively, if we start thinking about governance, governance can start to convert GraphQL into this more trusted layer that will allow those architects to use it further down the stack in order to be a bit more self-referential around the data that we've got access to. Effectively creating this kind of view here. And what this view here shows is that generally, when we're creating some kind of data pipeline with our system, we're defining data in some kind of data model. And in that data model, the data model may be good, it may be bad. We're presenting that with overlays of permissions. And then what we might want to do is create endpoints as a result of that. And so if we can combine all of this stuff together, if we can combine together the models that we're creating by maybe our database architects who are really, really sort of particular about third normal form, whatever that is, and then they're starting to say, OK, but we also need to integrate with something like Informatica to apply our policies, and we need to make sure that this customer here can't see these results, but our audit team can see these results. If we can generate any kind of metadata or generate any kind of GraphQL schema as a result of that, it kind of solves everything because it takes what our source is, it takes anything that we need to roll in from an authorization and governance perspective, and then generates the output, which is, as we talked about, the GraphQL schema that we're looking to generate. A few words for this. I think there's service mesh, there's data mesh, there's all of these different kinds of things. And I think I see GraphQL as the logical transport layer for the data mesh. So in a lot of data mesh conversations, we start hearing things around creating this service layer that has access to all data at all times and is able to produce relationships between that data, in effect driving value generation. I think GraphQL itself, provided it aligns with those governance principles and aligns with all of the metadata principles that we've spoken about, can provide that layer. The reason for that is that metadata itself enables governance. By describing the data, that's the thing that gives you the ability to govern the data. If you know who has access to that data, if you know how that data has gotten from A to B, if you know the security classification for that data, that's how that data can then be accurately governed. So a few things here, I think, when we think about things like consistency, collaboration, flexibility and compliance. These are all areas where metadata itself is going to be able to provide access to that governance. So things like consistency, as any kind of organization that works across a large enterprise, there'll be lots of different domain teams with lots of different databases and lots of different data that exists across it. And generally, when I work in those teams or when I work with those teams, there's a lot of differences. It's extremely heterogeneous because everyone decides that they want to implement things in their own separate way. And then effectively what you're trying to do is you're trying to move the point-to-point relationships between those different systems somewhere further in the stack. And then it provides a bit of a headache for someone else. So if we can generate metadata that defines what that data is in a uniform way, then suddenly it becomes really easy to join that data and manage how that data moves. Then it enables a lot more in terms of collaboration, because suddenly we can see what other people are doing, and we can look at their metadata, we can look at how it's declared, and we can say, I see what you've done. I want to join my data over here to your data over there, because we're all speaking the same language, even though it's an abstract language in itself. And so the reason that we move into more of a metadata approach is because it's more configuration instead of code. So as a bad developer, if I can write some configuration that allows me to generate code automatically, that's going to allow me, in effect, to produce more of that code. It's in essence going to allow me to be more efficient in what I do. So configuration itself allows far more in terms of standardization. It's one single standard pattern, even though we might have lots and lots of different outputs. It's easily repeatable. It's more declarative in its approach, which is kind of key to that metadata. And of course, it means that we can then roll things out with things like CI/CD. So if we start to think about configuration over code, it starts to make me think about these kinds of things here. So it's things like Puppet or Chef or Terraform or Docker or Ansible. These are things which construct something that's abstracted from what it actually is. I once tried to do a whole bunch of stuff in Puppet. It was really hard. But when you start to understand how it works, it means that you can start reproducing all of your systems, all of your servers in this case, in the same way. Now these things here, these are very much kind of the low-level server components, right? These are configuration management for servers. But there's no real thing that's kind of configuration management for your data or for your APIs. So it starts to make me think that maybe this metadata approach should be for everything rather than just for infrastructure. It also means that we start to become more ready for artificial intelligence. If we know how to prompt AI in the right way, if we know how to describe our data, if we know how to feed that data and that metadata in, then Gen AI, whether we're using public systems or private systems, will be able to better describe that data and better query that data for us. So if you give it metadata, AI knows how to parse the data, it knows how to query the data, and it knows how to understand it in order to achieve the goals that you're looking to get. Data discoverability is improved because, again, we start to be able to have access to all of those different data endpoints. We can start querying things that we didn't necessarily know existed because it's all defined in the metadata. The AI can get access to it. And similarly, we then start to have that compliance and audit approach because, again, everything is able to be checked off automatically as part of this approach. Now, I actually did this earlier on today. I fed some declarative metadata into ChatGPT and Claude, and then I also fed a GraphQL schema in. And I said, given this information here, can you write a query that gets me X, Y, and Z information? And Z actually didn't exist, right? I was being sneaky. And with the GraphQL schema, it was like, yeah, I think it looks something like this, and fed in the wrong information. But with the metadata, because everything was so clearly defined as being existing, non-existing, this is related to that, it actually produced the queries a lot easier. A couple of little logos. So I want to show you a little bit of a demo now. And what this demo is going to show is me looking at a data set, me then combining that data set in a way that allows for metadata to be generated, and then how I can then query that using both GraphQL and then also kind of natural language for a Gen AI approach. This is one way of doing it, but I think anyone's able to do it given the right metadata. I've lost my terminal. There it is. So you probably can't see it, but what I've done is I've just written this very, very basic script that runs like 6 commands. And what these 6 commands are going to do is they are going to generate a bunch of metadata from a data source. In this case, I've just said a Postgres database, but really we could choose any kind of data source that we want. With this metadata, we can then construct a graph, and that graph can allow us to then query it using something like GraphQL or pretty much any other protocol, right? As you can see, right down the bottom there, I'm going to select, hey, it's Postgres, and I'm just going to give it the pre-existing database endpoint. It's going to have a bit of a think, and what it's going to do is it's going to go and introspect the data source. So nothing special here. It's doing, it's adding these different models. It's saying, hey, there's a person value, there's a cart value, there's a credit card value. It's then going to construct the metadata for this. And then the metadata is going to be compiled into the GraphQL schema. So all of that happens automatically. But what you'll notice is that there's one extra step. We're not just compiling into a schema. We're compiling into metadata. And if we compile into declarative metadata, that then allows us to be a little bit more descriptive around what that is, which then allows us more context when we query that data itself. So now that I've done that, I need to open up the window that I've lost, this one here. Cool. Great. So what we've done is we've built some metadata. The metadata then defines what that looks like. And that there is effectively the org chart for where that data comes from. And if we have that org chart, if we have what that data looks like when it's brought into the system, we can then instantly generate GraphQL schemas from it. We can just generate REST schemas from it. I can write some queries that say, hey, I want to just grab the latest plans or something from that user. And there's my GraphQL, very, very normal kind of stuff, automatically generated. The interesting stuff, though, happens when we start to look at querying this with natural language. So I could say, hey, show me my top 10 customers, or something like that. And because the LLM can be fed with the context, it can be fed with the schema that describes the data, the LLM itself can then write the code that queries the data, that queries the semantic data layer, in order for us to pull the right data out of it. Make sure I've got signal in there. Nice, love that. Maybe I'll try and start a new chat. And while that's having a bit of a think, I'm going to show you a slightly larger example from one of our other customers, where effectively we start to look at things from the org-wide or the enterprise standpoint. So what we can see here is that this customer has moved things off into multiple different domains, because everything that is mapped in the data layer should be mapped at the org layer as well. So we can see they've got network teams and support teams, and all of this data moved into those different data domains. If everything can be scanned automatically and generated into something that maps to the organization, built automatically into metadata, then that metadata is able to then define exactly how that data is interrelated, and then we can use that for any of the purposes that we heard about earlier, whether it's things like compliance, whether it's things like AI, whether it's things like just simple queries. Might have to give this one a little look, but effectively, any kind of approach here would allow us to generate any kind of outcome, and effectively it looks a little bit like this. So our semantic data layer sits on top of any data source. We can then use any different way to query that, whether it's GraphQL or REST or PromptQL, and that effectively allows any kind of access across any different system. So I'll pause there. I want to give a quick plug to a couple of talks that I think other people might enjoy. So Ken, Andrew, and Anusharat, really good talks over the next couple of days. Otherwise, I would love to answer any questions you have about metadata, governance, or maybe GraphQL. I think you have to speak into this.
Or I can shout. So you mentioned that basically the schema and the metadata overlapping to a certain degree, right? As a developer, do I need to maintain both? Like, how do I reduce the redundancy across?
I think it depends on your role in the organization. So in my mind, it's not the developer's task to be writing schema or writing metadata, in my mind. I think the developer is usually going to be writing functions, and then things like schemas and metadata should generally be automatically generated as much as possible. Now, in places where metadata can't be generated, that's where you'd be writing declarative metadata, and then in my mind, the schema should be automatically generated. It should be an output rather than an input. So if you're there, if you think about those analogs of things like, chef or puppet, I might use one of the, I use mainly Ansible, so I might use an Ansible recipe, pull it down and go, right, I want to use Nginx, and then I would configure a couple of those little things like the Nginx port. Same thing with the metadata. The metadata should scan the data, it should pull all of that together, and then you could configure it to say, actually, that one's PII, we shouldn't allow that to be exported to everyone, and then the schema should be generated automatically.
Got it. Cool. Thank you.
Thanks.
You had a slide mentioning ontology and semantic data. That to me sounds like RDF, resource description framework, and JSON LD. Is that in any way part of what you're doing, or have you considered?
I mean, look, it totally could be. I think in terms of the thing that I think is most important to customers that I work with, it's data access. Like, everything comes back to being a data access problem. And if they have access to the data, then they can start creating data products, whether it's internal data products, external data products, as a result of that. So even things like creation of a data mesh, there'll be certain things that you can push into that or pull out of that, like things like ontologies, that really are able to be done as a result of the creation of a data access layer. So I guess the answer is maybe. Question at the back? Thanks.
Hey, I know when I first started building out microservices, like there was this thing about, hey, how each microservice should have its own database, and you shouldn't try to touch that from other databases. But with your solution, you hook right into every single database, and so that couples them all together again. And I'm wondering, like, how do you kind of square that? Because to me, that seems like an anti-pattern, but I'm sure you have tons of customers that have it work totally fine.
Yeah, really good question. So it's not coupling anything together. The data itself, the databases themselves, they are entirely isolated from everything. So you would manage your own database, you'd manage your data access, you'd manage how things connect to it and how things absorb content from it. I think the difference is that in the past, exactly what you're saying, right? In the service-oriented architecture world, you would create this, you create a very small microservice that does one thing, and another one that does another thing, another one that does another thing, and you would be responsible for managing those. I think what this is doing, and what I'm seeing a lot of organizations do, whether it's Hasura or anything else, what they're trying to do is they're trying to say, hey, we still want those data domains and we still want those teams to manage that data, full freedom over defining their data model, full freedom on defining kind of the auth rules and other things that would apply here. But what we don't want them to have to do is we don't want them to have to start creating all these point-to-point connections between lots of different microservices in order to draw everything together to provide the end data product. So, and we can talk about this, so, it's because it's perhaps a deeper answer, but we'll talk about this afterwards. What the semantic data layer does is it kind of creates the automatic graph that would allow you to draw information from multiple places together without actually having to couple that data or without having those databases or data sources know anything about each other. And so that's kind of allowing you to have data ownership at the domain level, but governance of things over the top of everything. But I'll show you a deeper example. Yeah, maybe downstairs.
Thank you.
Awesome. Thanks, everyone.